Hey everyone, welcome back to our channel where we'll simplify Java concepts for you. So today I'll talk about variable data types and how to use them effectively. But in case you haven't watched my video on variables, I would strongly recommend to see that as well. And I'll add the link in the video description. So let's get started. In my last video, we covered in depth about Java variables. So here I am in Eclipse. I'll create a new class called variables. Okay, right click here, simply click on this new class. I'll name the class as variables with a capital V as per the naming convention. I select this checkbox to include the main method and then I'll click on the finish button. So I have this class ready. Okay, I'll click here, I'll do command D to remove this auto generated comment. I'll press enter. Alright, so suppose if we declare a variable like this, int number equal to 10 with a semicolon. So it means I will have a container named number with the value of 10 inside, and in Java we also have to specify that number is of type what. In our case, it is of type integer. So int is a data type here, which means that the only values that are allowed to store inside the number variable are of integer type. Now we can have different type of values. For example, I'll press enter. Okay, I can have values like true, I can have values like false, we can have decimal values like 100.20 or even a group of characters like automation. So we can store all of these values inside our variables. Now these are totally valid values, but they are not allowed to be stored inside integer data type. So we can even update the value of a variable as many times as we want. So we can do something like this. So int number equal to 10, and I can do something like this. Number equal to number plus 10 with a semicolon. So the above statement is valid because number can store only integer values because of this int data type. Alright, and we can update the value of an integer variable, but the only condition is that the new value should be of integer data type. So using the variable data type, we can find out couple of information. So let me go to my whiteboard. Yeah, so this is the information we can get from data type. First, we get the size of the memory location, or in other words, how much memory this variable is actually consuming in memory. So we'll cover shortly how much size each data type consumes in our memory. Then second is the maximum and minimum possible values that we can store inside this container or the variable. And finally, the possible operations that I can do on this particular variable. Let me give you a simple example. I'll switch back to my Eclipse. Okay, yeah. So we can perform basic mathematical operations like addition, subtraction, multiplication and division on numbers, right? So I can do something like this. I'll do system.out.println and I'll do number times 2. This is asterisk key. I'll do a semicolon to mark end of my statement. Okay. Now we cannot perform these arithmetic operations on another data types like character or even boolean. So what all operations can be done on a variable is determined by its type. In this case, it is integer. Okay. So I'll go back to my whiteboard again. So data types in Java are of two types. Okay. Yeah. So we have primitive data types and then we have non-primitive data types. So primitive data types are the ones that are provided to us by Java, and non-primitive data types are also called user-defined data types, and they are the ones that are created by programmers like you and me. However, in this video, we'll learn in depth about the primitive data types. Alright, so primitive data types are further categorized into numeric or non-numeric data types, and inside non-numeric, we have Boolean and character data types. So let's talk about Boolean data types first. Okay, so Boolean data types. The Boolean data type is used to represent a binary value which can be either be true or a false. There is no third value for a Boolean type. So it's either just true or false. Now, suppose if I ask you a question, is Java simple? Now, it has got only two answers. Either you can reply in yes or no. So in Java, yes is called true and no is called false. And this is how we use them. I'll go back to my Eclipse again. Yeah. So I'll give you a very simple scenario. So let's say, suppose it is raining. Let me clear all this. Yeah, suppose it is raining and then we want to take an umbrella. And if it is not raining, then we don't want to take an umbrella. So this is how we'll write this particular condition in Java. I'll do something like this. Boolean is raining, which is following camel case convention because this R is in caps. So I've written true. And notice that there is no double quotes. Yeah. Okay. So I'll write an if condition. So I'll write is raining and then I'll do like this. I'll use system dot, I'll copy it from here Okay, and then I'll do else. Okay, so I'll remove this piece of code here and I'll use take an umbrella. If it is raining, take an umbrella, and suppose if it is not raining, then what I want to do is no need for an umbrella. Okay, I'll do this. All right. Yeah, and don't worry if you're not really familiar with this if and else syntax. Just remember that you're learning Java step by step, and with enough practice, you will like it. Also, a quick quiz for you. So what's the other method? So this is the first method that we have learned, right? So what's the other method that we can use other than this println that will help us to print the output to the console? I hope you remember it if you have watched my earlier video. So I would request you please write your code in the comments below, and if you're liking this, my style of teaching, so please do like this video and subscribe to this channel. So next we have is a character data type. I'll switch back to my whiteboard. Yeah, so this is my character data type. So char data type is used to store a single character, and they are those characters you see on your keyboard. Example, Q, W, E, or even capital letters when you press shift key, and Q, W, and E in capital letters. So not only uppercase or lowercase letters, we can also use plus or minus characters or even digits. So all of these can be stored in Java using the char data type. We call it character, but actually it is char, right? So I'll go back to my Eclipse, and this is how I'll write my char data type. I'll do like this, char. Let me write letter A again with camel casing. And in case of characters, we use single quotes, and here I'll type shift A as in caps. So this is how I'll define a character data type variable. So we have just created a container or a variable called letter A, which contains the character called A. Then we have numerical data types. I'll switch back to my whiteboard. Yeah, so we have numerical data types, and they are further categorized into two categories. One is integer numerical data types and floating point numerical data types. So integer data types refers to numbers like 0, 1, 2, 3, and so on. It can also include negative numbers like -3, -10, etc. Now, to store integers, we have 4 different types. We have byte, short, int, and long. Okay, and the only difference in these 4 data types is the range of values, that is the maximum and the smallest possible values that they can store. Okay, so I'll show you here. Right, so if we talk about byte, it takes -128 to 127. So we can store any number between this range, -128 to 127. So, and its default value is 0. And as I've written it, the size of this byte variable is 8 bits, or we can say 1 byte of memory, which is kind of negligible. So let me store an out of range value, let's say 130 inside. So I'll switch back to my Eclipse and I'll try to store something which is out of range in the case of byte variable. So I'll do byte of B equal to 130. And notice that 130 is outside of this byte range. So it can store maximum till 127. And I'm trying to store more than 127, which is 130. So I'll get this error. Now to find out what this error is, I'll simply bring my mouse on this. Okay, so it says type mismatch, cannot convert from int to byte. Okay, so we got this error. All right, so I'll simply comment this piece of code and I'll switch back to my whiteboard. Yeah, so then we have short data type, which has a bigger range than byte. So if we see, here's short, and the range of this short is -32,768 to +32,767. Okay, and its default value is 0, and it takes 16 bits, which is double than byte, or we can say 2 bytes of memory. And if you try to store a value, let's say 35,000, which is greater than this range, Java will again throw an error. So I'll switch back to my Eclipse. Okay, I'll come here and I'll type, let's say short, say salary equal to 35,000 with a semicolon. Yeah, and I'm getting this error again. Why? Because of this. So we can say the error is type mismatch, cannot convert from int to short. And if I'll include, let's say just 32,000, the error will be gone. Why? Again, we are using any number between this range. Okay. Then we have int or integer, which has a bigger range than short. If you can see, this range is huge, quite huge actually. And it can even store numbers from -2 billion. So this is -2 billion to +2 billion. Okay, which is quite huge and sufficient for the majority of our requirements. So its default value is 0, and it takes 32 bits, or we can say 4 bytes of memory in your RAM or random access memory. So to be specific, the highest value it can store is 2,147,483,648 here and 647. is with a positive number, and the last numeric data type, which contains whole numbers, is long, and it has even a far bigger range than integer. Have a look at this. Okay, so it has the capacity to store whole numbers with a magnitude of 9 quintillion, which is even hard to think about. Imagine you have a million and try to add 12 zeros to it. That will be 1 quintillion. Oof, unbelievable. Now, let me try to store a number which is, let's say, 3 billion into a long variable. Okay, so I'll go back to my Eclipse and I'll type something like this. I'll use long, I'll use L as my variable name. Okay, and I'll write 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 with a semicolon. Okay, now we're getting an error here. Here is the error. Yeah, so it says literal this of type int is out of range. Now, we are getting this error not because long variable is not able to hold this particular value, but whenever we write a number like this, Java by default interprets it as an integer value, which are default numbers. But we want this value to be stored as a long value. For that, we need to explicitly use either small l or capital L after the number. Okay, so let's try with small l. What I'll have to do is simply add lowercase l here, and the error is gone. Okay, let me try with capital L. Again, the error is gone. Okay, so this code also works. I'll do something like this. Long L1 equal to 300 with a semicolon. Yeah, so by default, the numbers are integers and 300 is within the range, and that can be represented by an integer in Java. So we don't have to use small l or capital L in this particular case. Okay, so Java automatically converts this int number to a long number. Okay, however, if we try to store any number which is outside the range of integer, which is, let me switch back to my whiteboard. So it is minus 2 billion to plus 2 billion. Okay, right. So in the case of this 3 billion, you must explicitly specify it as long by appending capital L or small l to avoid errors. Okay, so let me go back to my Eclipse. Yeah, now when we use such large numbers, we usually use commas. For example, 3 billion is what? It is 3 with 3 zeros, again 3 zeros, again 3 zeros followed by a comma. So these commas increase the readability of such large values. Now we cannot use these commas, but to improve readability, we can use an underscore in Java. So I can write like this: long L2 with a 3 underscore 000 underscore 000 underscore 000 with a capital L and a semicolon. And see, there is no error. Okay, so this program will compile and actually run successfully. So behind the scenes, what is really happening is Java will simply ignore the underscores and we use them only for the readability purpose. Okay, so let me switch back to my whiteboard, and yeah, the last two data types are used to represent the decimal point numbers, which is float and double. So let's talk about float. It takes approximately 7 decimal digits and takes half the memory as double. Okay, so if we talk about float, float takes 32 bits while double takes 64 bits, and default value of float is 0.0f. And to specify a float value, we append either a small case f or a capital case F, just like how we use with long, to specify that it is a float value. Otherwise, by default, any decimal number is actually considered as a double number by default. Okay, let me give a simple example here. I'll switch back to my Eclipse. Yeah, so these are my numbers with a decimal: 10.2 minus 4.5 or 1.2. So they are all double numbers by default. And notice that all of these numbers have a decimal point. They can be positive or negative or even 0. Okay, so if I want to write a float number, I'll use float as the data type, num, which is my name of variable, and then any value which has a decimal. Okay, and I'm getting this error. Why? I'll bring my mouse here and it says type mismatch, cannot convert from double to float. So it clearly says that 4.4 is a double value and it is unable to convert this double to a float value. So how will I get rid of this error? What I'll do is I'll simply make it float by adding a small f and the error is gone. So I'll write f. We can also add a capital F and again it will work like this. Alright, so the second decimal data type is double, which can store unbelievably huge numbers than float. See, this is the kind of range actually that double can use. Okay, and it takes approximately 15 decimal digits and consumes double the memory than float, which is 64 bits, or we can say 8 bytes. And the double type is generally preferred over float due to its greater precision and wider range, so making it more suitable for most floating point calculations. And the only difference between float and double is the range, that is the maximum and the smallest possible values that they can store. Let's see them in action. So I'll go back to my Eclipse again. Let me create a double value like this. I'll use double d equal to 2.7 with a semicolon, right? And this code will work successfully as by default all the decimal numbers are double only and not float, okay? But if we use like this, float say f1 equal to 3.4 with a semicolon, we'll get an error. Why? Because this number 3.4 is being interpreted by Java as a double value by default. So Java threw this error that we are trying to store a double value inside a float number which is incompatible. Okay, so we can simply use a capital F or a small f at the end of the value. So we are telling Java that this value should now be interpreted as a floating point value and not a double value. And yeah, we can use both negative values as well as positive values as long as it falls in the range of the data type. So here is the process of using variables. Yeah, so this is the process. The very first thing is we want to identify a type that you want to store a variable, and then second we want to name the variable using lower camel case where this L is in small, this capital C is in caps, and again this C is in caps. And third, we want to set the variable equal to the value that we want to assign. Okay, now suppose we want to store the number of students of a class into a variable. So we can choose a variable name using the lower camel case format, and the number of students will always be a whole number. So we can use any of the 4 integer data types like byte, short, int and long. Okay, these are the types that I was talking about: byte, short, int and long. So we have now 4 containers. When we move from byte to long, the required memory keeps on doubling, right? 8, 16, 32 and 64. So the memory keeps on doubling, right? And the range also gets significantly bigger. So which data type should we use to store the number of students in a class? Here's the golden piece of rule: use the smallest amount of memory possible. Now, if we are absolutely sure that the number of students in a class is never going to exceed beyond 127 at any point of time, which is the highest value of this range, right, then just go ahead and use byte. But if there is even 1% possibility that the number of students can go beyond 127, then simply use short, which can include any number between minus 32,000 and positive 32,000, which is almost sufficient to include the number of students in the class. But in this case, it will take 16 bits or 2 bytes of memory. And yeah, nobody is stopping you from using integers or even long to store number of students. And for a smaller program with less number of variables, it will hardly make a difference whether you go with byte or actually an integer. Okay, so you can use integer when performing arithmetic operations that might result in values outside the range of short. Okay, and the decision ultimately depends on your specific needs and coding style. And if memory efficiency is a critical concern, you might explore byte or even short in that case. But for most classroom scenarios, int is a safe and practical choice. Okay, so I'll scroll down here. Right, so again we'll go back to variables process. So after identifying the type, the step 2 is to use the name, basically name the variable using lower camel case format. And the naming convention demands that the first word starts with a lowercase letter, this L, but the words that follow start with an uppercase letter. Like it is a 3-letter word, so this is L is in lowercase, second word is in capital, and again the third word is again in capital. Okay, so I'll switch back to my Eclipse. Okay, and the name variable starts with a lowercase letter. If I'll write like this, name as my variable name, it will start as a lowercase letter. And if I want to use, let's say, phone number, I'll write variable name like this. This P is in small and N is in capital with the 2 words. And if my variable name has a 3-word, I can do like this: date of birth. So first name camel case, lowercase, this O is in caps, and this B again is in capital letters. And finally, the step 3 is to set the variable equal to the value that we want to assign. Okay, and now instead of running all of the code at once, what if we visualize it step by step? So there is actually a way to do that using breakpoints. So let us see how to debug in both VS Code and Eclipse. So from the terminal, I'll go back to VS Code. Okay, and from the terminal, I'll run the command called touch variables.java, where V is in caps. I'll press enter. Okay, and it will create an empty file, variables.java. Okay, I'll open this variables.java. I'll simply type class. I'll press enter. Okay, and then I'll do main, down arrow key, main. Okay, so it has created an empty skeleton for me. Right, now let's create a variable and print it out. I'll do int num of students as my variable name equal to 5 with a semicolon. Okay, and then I'll do system.out.println of num of student. Instead of typing completely, I'll simply press enter here with a semicolon at the end. Now, in order to debug this code, let me bring the mouse to the left of this line number here, and I'll simply see, okay, yeah, here, and I'll simply see this red dot. So wherever we click, the breakpoint will be applied, and instead of running this entire Java code using this option, run option, if we click on this debug button now, we can execute our code line by line and see what is really happening. So let me put a breakpoint here on line number 7. Okay, I'll also put a breakpoint here. Okay, and now what I'll do is, instead of clicking on the run button, I'll click on this debug button. So it has started debugging. All right, so the program is now running and currently paused here at this particular line, which is line number 7, and it is waiting for us to resume. And we can see VS Code is even showing the debug toolbar at the top. So this is the debug toolbar. Okay, and at this point, Java doesn't know about this num of students variable. So if we press continue, it will run the current line which is highlighted, and then it will pause on the next breakpoint, and again it will wait for the user to resume execution. So I'll click on this, which is the continue button. Yeah, I'll click on this. So it has executed this line, and now if we look here, this variable num of students has a value called 5. We can even see this value as here, which is the runtime value. Okay, now let me click on this continue button again. Okay, so the program has completed execution, and this is my final output here. Okay, right, and now since after this line there was nothing else to execute, so the program simply ended, right? Okay, so now we are done with debugging. So I'll click on this debug console. I'll simply bring my mouse here, and I'll click on this icon. It will close my debug console. Okay, and yeah, we can remove all the breakpoints individually, and there's an easy way, and that is to look into, click on this X icon actually. So let me click on it. Just observe, after clicking on this, these red icons will go away. Yeah, so these icons are away now, and the breakpoints are gone. So let me click on this Explorer icon to see back all the classes. So debugging is very essential skill that we all should be familiar with, so that if something goes wrong with our code, we can execute our code line by line and fix the issue wherever it is. Now let us see debugging in Eclipse, which is again very simple. So I'll copy this piece of code. I'll do Command C. I'll go back to Eclipse. Okay, I'll remove all the existing piece of code here, and I'll remove it. I'll do Command V. Okay, so in VS Code we applied the breakpoint with a single click. In Eclipse, we have to double click where we want to apply the breakpoint. So let us put the breakpoint on both the lines like how we did in VS Code. But here I'll double click here. Again, I'll double click here. Okay, so these are the two breakpoints that I've just applied. Now to debug in Eclipse, we'll right click, and instead of this run as Java application, I'll simply do debug as Java application, and it will start debugging. Okay, yeah, and I have to save my code. I'll click on OK. Yeah, and I see this particular dialog which is saying confirm perspective switch. Okay, so Eclipse is asking us to open the debug view. So let me click on the switch button, and we can see that the debug has started and execution is paused here. Okay, and this is the debug toolbar in Eclipse, and here is the resume button. So let me click on it. Okay, so it will execute the first line, and execution has paused here at this second line, and we can see that the current value of num of students variable on the right hand side. Okay, in the VS Code it was showing in the left hand side, here it is right hand side. And if we click on the resume button again, the execution is done, and we see the output in the console, and the program simply ends. I'll click on this resume button. So we see this output. Okay, and that's it. So debugging is very simple, and it's quite similar in both VS Code and in Eclipse. And yeah, in Eclipse we have to do just one more step. We have to do this, click on this window. I click on this perspective, open perspective, and Java. Okay, and I'm back to my earlier perspective. Right, so to recap what we have learned so far, right? So using the variable data type, we can find out how much variable this variable is actually consuming in memory. Yeah, okay, and then what we have learned, we have also seen the maximum and minimum possible values that we can store inside the variable, and finally all the possible operations that we can do on this particular variable. And data types in Java are of two types. We have primitive data types, and then we have non-primitive data types. Primitive data types are the ones that are provided to us by Java, and non-primitive data types are also called user-defined data types. And primitive data types are further categorized into numeric or non-numeric data types. These ones are numeric and these are non-numeric. Inside the non-numeric, we have Boolean and char data types, and Boolean data type is used to represent either true or false values. For example, if we ask the question, is Java simple? It has only two answers, yes and no. In Java, we represent yes as true and no as false. Then we have character data type. to store a single character, and they are those characters you see on the keyboard like uppercase or lowercase characters. Then we have numerical data types, and they are further categorized into two categories: integer numerical data types and floating point numerical data types. And integer data types refers to both positive and negative numbers like 0, 1, 2, 3 and so on. And there are 4 integer data types like byte, short, int and long, which differ in the minimum and maximum possible values that they can hold and the amount of memory they can consume. And for decimal values, we have float and double data types, where double is the default, just like how we have integer as the default data type. So that's it for this video. Please do have a look at the notes I have prepared for you specifically, and feel free to download them. And I hope you have liked this video. Please like this video if you have actually found it valuable. This actually helps this video to rank higher as per the algorithm. And please consider subscribing for more technical content. And if you are liking my work, please share it on LinkedIn or with your friends. And stay tuned and happy learning. Piyush Gupta, your virtual coach, signing off.